Great, thank you all for coming. I know most people's reaction when I start this talk because you look up at the screen and say, oh, it's about Windows, why do I even care? And we're at a conference, and looking around the conference, you're going to see a breakdown of people's laptops that look something like this, and you feel relatively justified. There's a lot of people with, normally I get to this talk and there's a whole lot of glowing fruit looking back at me. But of course, you go between the talks and you see a picture that kind of emphasizes that even more. And there's a real separation here. There's a lot of people on Mac. There's a handful of people on Linux from time to time. We've seen more of that here than a lot of other conferences, actually. So I do need to adjust this for PyCon Island, it seems. But then you come into my talk, and, well, it can feel kind of lonely. That said, these are all very anecdotal charts. There's no real data here. So you make of this what you will, and me being the minority in the room, though I've seen a couple of people waving PCs at me, which is nice to see, I may have a biased view. So let's go pull some actual real data and see what people are doing with Python. If you want downloads from pypi.org, you can get all of these. They're on Google BigQuery, free accounts, and there's also a few other sort of aggregation services that will give you the breakdown of who's installing packages from PyPI. Roughly, across a handful of packages, it tends to look like this. Vast majority Linux, and roughly equal Windows Mac. This is real data. If you look at the same thing for Conda packages, which are very popular in the data science world, you see more Windows usage, little less Linux usage on that. Last year, there was a survey run by the PSF. It's running again this year. And one of the questions, two of the questions, in fact, kind of implied what operating system you must be working on. And so we were able to infer from that about 50% of people who responded to that survey are actually running on Windows. When you look at people who are using Visual Studio Code, which is completely cross-platform free editor, great Python support, by the way, go check it out. But 50% of the users are on Windows. If you look at PyCharm, which more popular, but it's far more popular on Windows. You're up to about 70% of PyCharm users are running on Windows. And then for the final number, the downloads from python.org. This is not publicly available data. I had to ask permission to get it. This is 1 month worth of downloads from python.org. Now, OK, to be fair, no one on a Linux machine goes to python.org to download Python. More people should be getting it for Mac from python.org because the installers there are good. But just for context, no matter what the breakdown is, this is 14 million downloads of Python for Windows in 1 month. 150 million downloads or more a year of Python for Windows. So that's a really big number. That's a really big number. And when you start slicing up the actual numbers, you see that the Python community looks something like this. There's a lot more Windows users than what we see when we come to conferences, what we see when we look at people publishing packages online, people blogging about Python, people tweeting about Python. We get to see this area. This whole time, there is a big gap, because half of this screen would never consider coming to a conference. They're not here. They're simply not engaging in the Python community in a way that we can see. And I think that's a real problem, because that's half of our community simply left out of what we're doing. Now, let me be really clear. I'm not saying this is conferences' fault. I'm not saying the conferences, you need to get your act together, start including all these people, make them come. That's not what I'm saying. If you feel like I'm saying it's your fault, don't hear that. I'm not. This is not meant to be an attack on you. I love that you're here, no matter what kind of machine you're using. But since you are here, let's talk about the parts of the gap that you may have some control over. Because while it's not specific to any particular OS, Python does an incredibly good job of spanning all operating systems. It makes it easier to write cross-platform code than to write platform-specific code. But that's just Python. And Python without its libraries is nothing. Users rely on your libraries, the libraries that you own, the code that you publish to PyPI, that you share on GitHub. are part of what Python is. And so when that doesn't work, that welcoming committee starts feeling a little bit rough. In this session, I am going to go through 5 common things that people have to worry about when producing a library. For each of them, I'm going to address 2 false assumptions that people make, 2 things that are commonly believed that are wrong, and I'm going to give you 1 recommendation for each one that will help you produce better code. At the very end, there'll be 1 simple checklist. That's when you get your cameras out, because that will be the things to check in your library before you release it next that you can do to make your code work better across a range of platforms. Spoiler, all of these actually make your code work better on any platform. It will make your code more maintainable, more reliable on Linux, on Mac, on Windows, on Raspberry Pis, on MicroPython, on CPython, on IronPython, on Jython, wherever your code is running. This is just generally good coding practice for working in Python. That also happens to make your code more reliable on the operating system that has the majority of Python developers. So, let's get started. This seems like an obvious question, but it is something that you do need to worry about. And the second part to this is, how do people run your Python script? So, really big assumption that people make here is that everything is on path. So on POSIX systems, we tend to have like a 3-layer, sometimes more, sometimes less, structured path where your scripts will be installed into. You've got a user directory where scripts go into, and if someone types a command, the system's going to look in there, find the command, run it. If not, it'll look in the site or dist directories. If it's not there, it'll look in the system-level directories, and eventually give up and give you an error saying, I can't find this script. And so a lot of people will say, oh, to run this thing, simply type, I'm going to mention black a lot, not because black gets any of this wrong, just because the more I talk about black, the more people will remember it and go use it, which is a good thing. But the instruction is type black. And after you've installed black, it shows up somewhere on path. OK, Windows, this is not how it works. On Windows, path is intended to contain the system files. It's also customizable, which means if you install an app and you want to access that kind of globally, then you can put your app on the path as well. And because you can do it, it means someone else can do it, and they can put their app there. And it means someone can find themselves a bonus and put theirs right at the start, because they're the most important app in the world. And you'll notice that that comes before the system files, which means all of those dynamically loaded libraries from the system that other programs are expecting to find, they're now getting them from that app. And basically, all of the commands that you thought you were going to, as soon as the path changes on Windows, you're rolling a dice every time you type a name. As a result, Python does not put itself on path on Windows because it's complicated to get it correct. It's complicated to get it correct in the context of multiple versions of Python to the point where it's not worth trying for the most part. So there are other mechanisms for finding where Python is and being able to launch it. Next part of this assumption, people assume that typing Python 3 will launch Python. Not always true. On Windows, it's called Python, python.exe, but it's always Python. There's no version number as part of it. It's just always Python. Now, what else gets installed is a launcher that's called py.exe, but that's kind of irrelevant. You don't need the extension to launch a program. Py is a special tool that knows how to find Python. It uses other ways to find the ones that are installed, no matter where they are, and it will find it and run it and pass all the arguments through. Which means that if you type py, my script, py, my commands, it will find the latest version of Python and run it with that. So, a recommendation for libraries to make sure that your code is easily runnable all over the place. The -m option to Python says, treat this as a module name, as if I was importing it, but run it as the main script. If you haven't seen this before, you'll have to go and look up how to actually implement it. It's not complicated. But what it means is that rather than saying, after you pip install black, type black, you would say, type python-m black. And that will go off and find it and run it in the context of the copy of Python you've specified. What this means is that people using py.exe can launch your script. If the only option you give them is a setup tools entry point, then that option isn't available. This is actually good for all platforms because it works with the specific version of Python you set. The recommendation for using pip these days on all platforms is to type python-m pip. The reason is because if you type pip install something, it will go into the copy of Python that pip is installed into. If you then type Python, you might run a different copy of Python, and then you can't import the package you just installed. Python-m pip never has that problem because you've guaranteed which one you're running it in. And so it's simply more reliable everywhere. But please, document this. If your README on GitHub simply says, after you install this, you can run it by its name, people won't know that this is an option. And simply by saying, it doesn't even have to be in the first example. It can be the last example. This can also be run as python-m my name. And it might end up being different. Sphinx, for example, has multiple commands. You may have to add an extra level of command line arguments. But documenting it means that people will know that you've thought of them. You've considered their situation, and you've given them a way to use your code. How do I handle paths? This is a fairly obvious one, because we all know this is not true, right? Everyone uses forward slashes in their paths. Well, okay, until you get onto Windows, and suddenly everything is backslashes instead of forward slashes. Which means all those places where you wrote this is not going to work. The string functions are not path manipulation functions, so if you're string splitting on forward slash, that will actually only ever split on forward slash and not other path separators on other OSs. Yes, I get that there's not really any other OSs that use backslashes. Windows is the exception, but at the same time, it's the exception with most of the users on it. So it's worth factoring into the code that you write that a forward slash is not going to be universal. And just to make it even more fun, Windows will understand a path with forward slashes if you give it to it, but every time it gives you a path back, it's coming with backslashes, because that's the way it actually is. It does some transformations when you give it something that is not quite what it expects. The second assumption I see people make all the time is that you actually understand how to manipulate paths. Which, don't be offended, but that's false. You don't know how to manipulate paths. Pop quiz. This is the root directory. Is this a root directory? Yes, it is. This is a root directory, 99% of the time. This is also a root directory. Okay, splitting on backslash is now looking pretty bad. This is not a root directory. This is a machine name. Glad you knew that. This is also a root directory. And it will work in exactly the same places as that C:\\/ will, provided that root directory actually exists, which I can guarantee it does. It's not going to be that same GUID. You don't know how to manipulate paths well enough to do it by hand. So just don't. One simple idea, recommendation here. Use pathlib. Use pathlib. There's a whole lot of os.path functions as well, but since we're all on Python 3.4 or later, right, we can use pathlib. And those of us who are not can use the backport of pathlib. This is an object-oriented path manipulation library that is standard in Python and lets you wrap up all your paths in an object. Once you have that object, you can use the slash operator to extend it. This is path.join. But it's going to work with forward slashes everywhere because that's the operator that's being used. There are properties for reducing it, for finding various parents. There are functions for replacing parts of the path with other names or other suffixes. There's a number of file system functions on there. Glob, I find myself using all the time, because nicely it will return more path objects. As of Python 3.6, there's a protocol that means you can pass in a path object practically everywhere a file name is expected, and it will just work. And comparisons are handled. The case folding that is required on case-insensitive operating systems is handled automatically by these objects. If you're writing simple string comparisons, you're going to run into problems on case-insensitive file systems that pathlib will handle for you. where do I keep settings? This is most important for command line apps or GUI apps. Libraries less so. But a common assumption that I see being made is that tilde is the home directory. It's the user's home location. On Windows, no, it's not. Tilde is simply a valid character that can appear anywhere in any file name, including the directory that you want to put things in, but it will be in the current directory. So tilde is nothing special. It doesn't link anywhere. It's just another name. It doesn't go to the home directory unless you run it through a specific function that's going to find tildes and replace them with the home directory, in which case you know what you're doing. But I also want to suggest that tilde is not the best directory to store settings in anyway. Anyone who, like me, occasionally logs into their Linux machine and does an ls-a as soon as you log in, and there's 100 dot files in there, I mean, really? That's not nice. Windows, very similar, because not only once you find the user profile directory, that has more directories in it. It's not actually the place where the user lives. It's a place where the directory used by the user lives. And so it has documents, it has pictures, it has videos, it has subdirectories. And then these are exposed to the user through other mechanisms directly. It also has a set of configuration folders, app data, application data, and that comes in local and roaming forms, which, depending on the user's configuration, are possibly going to be copied to every machine they ever log into, or are only going to remain on the current machine. And now I have to say, do you know which of these is the right one to put your settings in? And again, the answer is no. And so the recommendation is use appdirs. This is a neat little library. It's a single file. It's a friendly license. You can copy-paste it into your code if you don't want the dependency. This provides a selection of functions that will basically switch on operating system to give you a good location for your app's settings. So if you're storing user data, user configuration, cache files, log files, if you're accessing machine-wide files, you can get the recommended directories for those on all operating systems, and it's fairly straightforward, simple calls. To add one extra thing that came up recently on a bug where I was discussing this, if your library or tool already lets people configure a directory through an environment variable, that's great, leave that there. But the default directory, if that isn't set, should be a sensible one for the operating system you're on. Which text encoding should I use? The web has started to break us a little bit because it's a very common assumption that UTF-8 is always correct. And that is not true. Okay, history lesson time. History lesson. What happened in 1985 and what happened in 1991? In 1985, we saw the first release of the most backwards compatible operating system to have ever made it onto our PCs. 6 years later, we have the release of Unicode 1.0, which defines universal code points for all the characters you're ever going to need. Asterisk, I'll come back to that. Which means that Windows, when it first came out, had a set of APIs that weren't Unicode because there was no Unicode to implement. And those APIs still exist. If you're implementing anything using the Windows API directly, there's a set of functions kind of known as the A functions and the W functions that take different types. So character, 8-bit characters versus 16-bit. These use what's known as a code page to map to their actual characters. So the code page is an extra global setting that says, for all the values between 0 and 255, here is how you map them to a character for this user's machine. Which means if you change that, you've just changed the reinterpretation of a whole lot of numbers. The WCHART ones take UTF-16, strictly UCS2. Talk to me afterwards if you're interested in the difference. But that is the difference between the two APIs. Additional history lesson. What happened in 1993 and what happened in 1996? 1993, Windows NT was first released. This was essentially a rewrite of Windows where the internals are fully based on Unicode. So it's Unicode the whole way through. This is actually where the W APIs came from. They were first introduced in Windows NT in 1993. What happened in 1996? Unicode 2.0, which was when UTF-8 was standardized. So if anyone asks, why doesn't Windows do UTF-8 the whole way through, or even properly? It's because UTF-8 did not exist at the time when the last big rewrite of Windows happened, and compatibility constraints now make it practically impossible to go back and change that. So the internals of Windows are UTF-16, and UTF-8 basically never comes up as a reasonable option on Windows. Second assumption, bytes are not text. False. Okay, it's too many negatives here. What this assumption commonly leads to is people on POSIX machines saying, oh, if I get a directory listing as bytes and then pass it back to the OS as bytes and never actually convert it into a different encoding, it will always just pass blobs around. So if there's some undecodable character or some weird sequence in someone's file name, then I can get that in as bytes, and if I get it in as a string, Python's going to crash, so I'll take it as bytes and pass it back to the OS as bytes, and it always knows what I'm talking about because it's just bytes. This is not the case. But when it leaks over, it becomes a problem. Because like I just said, on Windows, internally, everything is UTF-16, which means if you get bytes back from the operating system, they have been converted from Unicode back into arbitrary bytes. If you pass them out to the operating system, they're going to go through the code page, which means whatever the user's global setting says is how those characters are going to be interpreted, and not every single character is handled by that. And because of the legacy APIs need to work more reliably than crashing, you get question marks. So even though you're getting bytes out, bytes in, they may be corrupted, because internally they are understood to have a formatting that gets mapped through that can break things. So bytes are not always, bytes may be text, even though we commonly understand that bytes are not text. Okay, simple idea. Don't use bytes, use str. Python's string type and Python's operating system functions have been written and designed to handle these cases just fine. The concern about reading arbitrary bytes from a POSIX file system and having to pass them back is totally handled. The file system encoding will preserve those characters. They may appear like garbage in your string, but that's because they are garbage. That was what you were worried about in the first place. But when you pass them back out, they'll be converted into the right thing. On Windows, you're starting from Unicode, keeping it as Unicode, passing it back as Unicode, and so everything just works. However, what I will say is, when you're reading and writing to a stream, you need to know what encoding that is, because no operating system can guess or tell you what your user data should be. The contents of a file is controlled by you, your code, or it's controlled by your user. Either way, you have to specify the encoding. Now, maybe you specify it by letting your caller specify it to you. You have a function that opens a file that's going to decode it to string, and you don't have a parameter for the encoding, then you're guessing. Resist the temptation to guess. Everyone's suddenly interested in my answer to this. How do I make my code work? Again, specifically in the context of Python works fine on Windows. A lot of people still assume that nobody can install on Windows. This has not been true for a long time now. As of Python 3.5, you don't have to be an administrator to install Python on Windows anymore. And the amount of positive feedback I've heard from that has been huge. There are students in third world countries with 10-year-old laptops that can now install and use Python on their mom's work machine, even though their mom's not allowed to install stuff, because they can use Python now. Wheels are practically a standard format. If you were around for the introduction of wheels on PyPI, you may remember they were Windows only, because Windows was the only operating system backwards compatible enough to make it safe to publish precompiled binaries to a public server. And the amount of work that's gone into making that also work for Mac and most versions of Linux is incredible. But Windows was first because it just worked. So this is really not a concern anymore. Python installs fine. 90% of packages will install fine as wheels. If you need compilers, compilers also install a little bit more work. Again, Windows is not a developer's operating system by default. you have to enable that. And so it doesn't have a compiler, because think about all the members of your family that use Windows, and how many of them also use a C compiler. And I suspect it's practically none. But it's easy to install the compiler. It's easy to install the tools, and it's easier to release a wheel so that no one actually has any trouble installing stuff on Windows now. This is not a valid excuse. I hear people say a lot that they can't test their code on Windows, and that's why they don't support it. This really bothers me, because it's not that you can't, you can. More than half the Python community is testing your code on Windows when they try and use it, and it's failing. You can test on Windows, you just don't want to. That's fine, but admit it. Saying that you can't do something is saying that it's impossible. It's clearly not impossible for you. Maybe it's going to require time. It's going to require some investment. Does half of your potential audience deserve that investment? Or are you simply cutting them out because of laziness? I care about this one. You get two simple ideas. Get continuous integration, or get collaborators. Now, there are many free continuous integration providers that will happily build and test your code on Windows, on Linux, on Mac for free. Azure Pipelines is one that I can tell you more about. It is all three platforms plus any Docker containers you want, 10 concurrent free builds with no monthly quotas for open source projects. Come and talk to me if you want to know more about that. A lot of major Python projects in particular have been jumping over. Pandas is using it, Tox is using it, pipenv is using it. It's really making an impact, and I'm very happy to see that. appdirs is still around for Windows builds, and obviously Travis Jenkins are going to cover off your other platforms. But you can also get collaborators. This is a community. We want to invite people in. But part of that is actually extending the invite. If you don't have the patience to test on Windows, but you know your code may be used there, put a note on your README. I have not tested this on Windows, but if you would like to help, here's how to get in touch with me. If you can run tests once a release and let me know how things are looking, let me know. If you can build a wheel for me that I can upload, let me know. And actually invite people to come and help you with your code to make it work better for the users on other platforms. You can do the same thing for Mac and Linux if you don't live on both of those platforms. And what that gets you is more collaborators, more people interested, excited about your project. You start building a community around this thing that you care about, and you get to start having more impact beyond simply writing a cool bit of code. So, where to from here? Here's that checklist. Before you release the next version of your library, ask yourself, does -m work? Can people launch my project, launch my tool using -m? Do I manipulate paths by hand with the string functions anywhere in my code? Do I put configuration in weird places, or is it the places that are standard for the operating systems it's running on? Do I keep text in non-string types? And do I have continuous integration or collaborators on my project that are helping make sure that it can be used by everyone in the Python community? We have a gap between the people that we see using Python, the people we see working on Python, working with Python, and the reality of who is actually doing that. While it's not a complete fix, the welcoming committee is our libraries. The welcoming committee is the code that we put out, and the more we can make that, make people feel like they're being accepted and are part of our community, the better off we'll be. Thank you very much. My name's Steve Dower, Python developer at Microsoft. Go PyCon. I don't normally have time for questions, but this time I do. So if people would like to ask, yes? Do I find anyone moving to the Windows subsystem for Linux to avoid the problems I describe? Actually, no. what I see is people moving to the Windows subsystem for Linux to avoid the problems that Mac puts on you when you want a Linux-compatible system with a decent GUI. Something that can do proper Linux, binary-compatible Linux, but also when you plug in a projector, you get a screen. That's why I see people moving to WSL. There's always a lot of suggestions that if a library doesn't work on Windows, your users can switch to Linux completely. I don't think that's a good recommendation. If they're using Python on Windows, it's for a reason. And telling them you should switch into this borderline virtual machine that you have on your computer just to use, and transfer everything. Because now you need to install every single dependency in Linux as well. There isn't like a library by library crossover. So I've seen very little of that, but a lot of happy developers to be able to be on a Windows machine that also has 4 or 5 fully compatible versions of Linux available without virtual machines. Yes? Oh, sorry, we have one over here.
I have the microphone.
He has the microphone.
Thank you very much for putting the record straight for Windows. We use a mixture of Windows, and all the servers are Linux, but the developer machines are all Windows. We're developing Python on Windows and executing it on Linux, and we've bumped into all these things. So thank you very much. Very clear. There's one, and by and large, it just works. There's one thing I'm curious about, though. We do quite a bit of XML, and we use LXML library. For some reason, we have to jump through an extra hoop to get that on Windows. I think it has to do with a shareable library or something, but do you know about that?
Yeah, I do. LXML is using, I think it's using libxml2 internally. I believe it has wheels at this point. So if you're pip installing LXML, it should just work. And I know this because I used to use it as my example of something that you couldn't just pip install. And then they went and published wheels and broke all of my examples. So I'm fairly sure you can do that. But yeah, one of the problems with compiling C libraries on any operating system is the extra dependencies. And so you get a lot of Python libraries that are, oh, I've got this great C library, this great native library that I want Python bindings for so I can use it from Python. And so maybe you can compile the Python bindings just fine, but you also need the C library. A lot of those are Linux libraries, GNU libraries, things that are built into that operating system that don't exist or don't exist in that form, in that interface on other operating systems, which means you run into a problem like, oh, I need secure sockets, so I'll just wrap up OpenSSL. And what you've then done to your user is said, oh, you need to get OpenSSL working on your machine before you can use my little library to do my one cool thing. And that's just an unfortunate state of things. The operating systems are fundamentally different. And while Windows does have much of the same functionality, it gets wrapped up in totally different ways. So ideally, we would have like major contributors to some of these libraries to be able to have them switch in a big way. And either, like most of the time, we see things like the backend, like the backing library gets ported. Sometimes, and I would like to see more of, oh, you're using something like libcurl, I think, does a good job of this, of using the Windows implementations for TLS and HTTP rather than OpenSSL if you happen to be on Windows. And that's something that I would like to see, because quite often the operating system functionality is best. And for Python on Windows, we lose a lot of that because of libraries that require the POSIX libraries rather than the Windows APIs. Mike?
How does conda fit in the picture? What's your take on conda for the conda for everything? It's pretty much abstracts operating system away to most of the
Yeah, so the question is, what do I think of conda? I love conda, but ultimately conda would not exist without a lot of people doing a lot of hard work. And it's a lot of people, so conda is a package manager from Anaconda Inc., formerly known as Continuum. They employ people who go out and figure out how to build all of your libraries on Windows, and then they just build them for you and distribute them for you, and you likely never find out that they're doing that. It's even possible that your libraries are on Conda Forge, which means some random person on the internet wanted it so badly that they just went and wrote the build steps for your library and are distributing it without your knowledge, without your permission. Don't know how you feel about that. You can have it taken down if you like. But ultimately, it's the result of a lot of people doing a lot of hard work. I would rather see that distributed amongst the original package developers. Because frankly, if you are doing a package and you release it once a year, that's one build per year that you have to do. Whereas there's someone out there who is spending their full-time job figuring out how to build every single library and doing that day in, day out, just to make sure people can use your code. Yes?
Thank you very much. I really enjoyed your talk. I thought it was a great look back at kind of some of the historical problems, some of how we've got to where we are today and how good it is today. I guess my question really is this as good as it gets? What do you see coming next? What do the future versions of Python hold? You know, those leaps forward like py.exe and 3.5, what they brought. What's coming in future?
I hope it's not as good as it gets. There are a number of things that I'm personally working on, which I can't really talk about just yet, but I'm certainly investing a lot of my time in CPython contributions to thinking about this problem. How do we make it easier for Windows users to get Python, to get packages that work, to be able to follow instructions that were written for other platforms? That's one of the things that I've been trying to achieve for a long time, is if someone stumbles across some old Unix instructions, how do I enable that to just work on Windows in a way that people still succeed? Because as much as it may seem like I'm trying to guilt the people writing the instructions into doing it right, I care less about that than the people reading it actually achieving what they're trying to achieve. So if I could access all of those users, and I do from time to time, then I'll be teaching them stuff like, here, people write Python 3, and what they mean is py-3. So if you see that, you can, and give them the help that they need. For this audience, I want you to fix your instructions, because ultimately, I would love everything to just work with the same set of instructions. But that's not the case today. So the way that you can make a difference today is simple updates to instructions so that people can achieve what they're trying to achieve. In the long term, hopefully we'll get to a place where things just work nicely for everyone. Again, we all love the idea of utopia. No one's quite sure how to get there. And it's certainly not going to be here anytime soon. Any other questions? No. Great. Thank you very much.